All right, so first question we're going to look at is adding two vectors together visually. So here's the two vectors. So we got v and w, and I want to do v plus w. So how would I visually represent that?
You would move the w, the end of not that point, the other point, to the end of the arrow. If that makes sense.
All right, so put this one
At the end of the arrow.
end of the arrow.
Yeah.
Okay, so we line them up so the end point of v and the beginning point of w are just like that.
Yep.
All right, and then what?
You have to connect the beginning of the v and the end of the w, and that will be your final vector.
Yep. So connect beginning of v to the end of w, and that is exactly what v plus w looks like. Is there any question on that? So what I might do on the test is give you two vectors, have you add them visually, and you might have different choices, like A, B, C, or D, which one it would match up with.
That seems easy.
Okay, so next question we're going to look at is finding a position vector. All the problems that are on the test are going to be in both. You'll see a 2D problem finding position vector and then a 3D, but it's still the same idea. Okay, so we'll focus on the 3D. All right, so to find the position vector, what would you do to find the x-axis component?
You do 2 minus 3.
Okay, so 2 minus 3.
Second power, or would that just be it?
Nope, for finding position vector, it's just the difference between the x's.
Okay.
And now, what's the next part of it?
You do 4 minus negative 1, which would be plus 1, which would be 5.
And then the last part?
6 minus 5.
6 minus 5. So when we simplify that, what do we get?
Negative 1, 5, and then just 1.
And 1. Okay, so that's how you would write the answer using what the book calls an algebraic form. How would we write it with the ijk?
What do you mean?
So how would we write this as a unit vector?
Not sure.
So that's where you have like something and then an I, something and then a J, something and then K.
The negative 1i
So yeah, you can do negative 1I
plus 5j
5J
plus 1. What would the last one be? Be k?
Yeah, if you want to, you can leave the ones off if you want.
I thought k's were only for 3D. Are we doing a 3D one?
Yep, that's 3D.
Oh, okay.
Because that's X, Y, and Z in the coordinate. Yep. And there's the same answer as unit vector.
Okay.
Any question on finding a position vector?
Oh.
Okay. All right, so next topic we're going to look at is adding and scaling vectors. So there is adding, subtracting, and scaling. But if you can add, subtract is the same thing, except subtracting the components instead of adding. So let's add v plus w. Okay, so what would you get for your x-axis component when you add v plus w up?
3i.
So yep, we get 3i. And then for the y-axis?
2j.
Yep, 2j. And the z-axis?
Negative 2k.
Negative 2k. So there's v plus w. And now I want to find 2w. So that's a scalar product. What would 2w be?
Just give it to you. It'll be 2i plus 10j minus 12k.
It's 10j minus 12k. Yeah. So any questions on finding a sum, a difference, or scaling a vector?
The ones on the test are going to be harder than that, or are they going to be somewhat?
Pretty similar to that. Again, you'll have some in 2D and some in 3D.
What would a 3D one look like?
That's 3D because it has I, J, and K.
Oh, okay. Yeah, I get it now. Yeah.
Yep. Okay. So next question we're going to look at, we have a vector, and I want to find the magnitude of that vector. Okay. What's the formula that we use to find the magnitude.
Not sure. What is it?
So the formula, let's go back to right here, I think. So the formula for finding, actually it's one page before that. So the formula for finding the magnitude is right there. Where the x1, the y1, and the z1, those are the components of vector v, x1, y1, and z1.
Okay.
All right, so that's our formula. Let's go back to our example. And how would we find the magnitude of that one?
You take the x and, well, first you'd do it all to, what's it called? You square root everything.
Yep, so you're going to start with that square root symbol. And what's the first thing that goes under there?
6i.
So the I, the j, and the k are not part
Just
of it.
6.
Just
To the
6.
second power.
To the second power?
Yeah, then plus 2 to the second power.
Okay.
And plus 3 to the second power.
3 to the second power. And what's 6 to the second power?
36.
So it's 36. And 4 to the second power?
4.
And 3 to the second power?
9.
Okay, if you add those up,
49.
you get 49, which means that the magnitude of this vector is
7.
7. And what is the magnitude? It tells you,
How long something is.
so this vector is 7 units long.
Okay.
All right, now, is that vector a unit vector?
Yeah.
Okay, how long does a unit vector have to be?
1.
How long is that one?
7.
7. So is it a unit vector?
So it has to be exactly 1 for it to be a unit vector?
Yes.
Oh, no.
No, so that's, it's not a unit vector because it's not 1 unit long. This is 7 units long. What would you have to scale vector v by? So instead of being 7 units long, it became 1 unit long.
7.
Well, if you scale it by 7, then it's going to become 49 units long.
Oh, 7.
What is it?
Like a 7.
Yeah, 1/7. So let's find 1/7 v. And that's going to be a vector that points exactly the same way as the original, but it's going to be 7 times shorter, and that means it'll be a unit vector.
Yeah.
So what would be your I component if you multiplied by 1/7?
1.
Well, what's your I component now?
So it was it not 7? Or what's the I component?
That's in the original problem.
Okay. What is the I don't know what the I component would be.
So it would be 6.
Oh, okay.
That's the number in the original component. Well, it's not the I component. It's the x-axis component.
Oh,
it's the
oh.
number in front of I.
So it'd be 6 to the 7, or 6. Really bad 6. Six divided by 7.
Yeah.
That's what I'm trying to.
Yeah. So 6/7, and then what goes next to it?
2 7s or plus 2 7s.
Something before that.
I
I.
plus 2 7s. J
7s J. Yep.
plus 3 7s. K
Plus 3 7s K. And what kind of vector is that again? That's a,
unit vector.
yeah, that's a unit vector. Because it's 7 times shorter than the original one. And the original one was 7 units, so it must be 1 unit exactly.
Yeah.
Yep. All right. Any questions on that?
It's probably gonna come up on the test. Yeah. Well, a question like this.
Oh yeah.
Okay.
This will definitely be a
You have
test.
to make it into a unit vector.
Yes.
Okay, yeah, I think okay, that's all.
Okay, so the next question, we're going to look at finding the dot product. So can you tell me the first two things we would multiply together to get v dot w?
The 3 and the 4 and the
Okay.
first one.
All right, and what would come next?
The 2 and the -1.
Anything before that?
Would you multiply those together first?
Well, we're going to multiply those after, but there's something I need to put here.
Plus?
Plus.
Oh, well, yeah. And then 2 and then -1. And then -1 and 1. Or plus, or no, minus. Wait. No, plus. And then 1 at the end of all that, which wouldn't make a difference, but yeah.
Okay, so 3 times 4 gives me
12,
12, and 2 times -1,
-2,
and -1 times +1.
-1,
-1. Okay, and what's 12 minus 2?
10,
10, and 10 minus 1?
9,
Okay, so the dot product there is 9.
yeah.
Okay. All right, so now we have the dot product, v dot w. Now let's find the magnitude of v. Okay, so what would that be? The square root of what would go first?
That would be, well, what would it be? Because, yeah, I don't know. Would it be 12 or no?
So you got to square each component for the vector, add them up, and then take the square root. It's the Pythagorean theorem in 3D.
Yeah, what would you put? Because there's 2 different sections, so what would you put for the first one? Would you put them both in?
Well, you're using the components of vector v. So we're not using w right now.
Oh, you're using B, okay, then,
B.
yeah, that would be a 3
3,
I.
no I, but 3, we have to do something with the 3.
3 squared.
3 squared, which is
9.
9. And then the next one,
That would be 4 because 2 squared is 4.
so 4. Yep. And the next one,
Would just be -1. Wow, -1 squared would just be -1, right? No, that would be 1, it would be 1.
positive 1.
Yeah.
Okay, so what's the magnitude of v?
14.
9 plus 1 is 10, plus 4, yep, square root of 14. Now let's find the magnitude of w. So that's going to be the square root of,
16.
yep,
Plus 1.
plus 1, yep,
Plus 1.
plus 1. All right, so that's the square root of
18.
18. And now that we know the magnitude of w, the magnitude of v, and the dot product, what can we figure out between those two vectors? What do those 3 things help us to do? It was the formula you read earlier to me.
To find the angle.
Yeah, to find the angle. So now we're going to find the angle between v and w. Okay. Well, what's the formula to find the angle between v and w?
Cosine theta is equal to u dot v over magnitude of v and magnitude of u, or u and then v.
Okay, so cosine theta equals, and what's going to go in the top in our case?
U dot v.
Which is?
14, 18. Square root of 14 and square root of 18.
Is square root of 14 u dot v?
Oh, no, the 9.
9. So it's v dot w in our case. So it's 9 in the top. And then in the bottom?
That would be square root of 14 and square root of 18.
10 square root of 18. And how are we going to get theta by itself?
you would put, I don't know what it's called, cosine -1.
Yep, inverse cosine.
Inverse cosine, and then you would like all the things. I don't have a calculator on me, so I can't do it right now.
Okay, so we need the inverse cosine of 9. Inverse cosine of 9 divided by square root of 14 times square root of 18. Okay, you type it in just like that.
Okay.
And then we hit enter. Let's make sure we're in degrees. And that gives us an angle of 55.46 degrees. So that's the angle. Now, with that angle, does that mean these vectors are parallel, perpendicular, or neither?
Neither.
Neither. If they were perpendicular, what would that angle have come out to?
Something divisible by 45, right?
No, it would be an exact, well, the number is divisible by 45, but it's an exact number.
45.
If two things meet at a 45-degree angle, that's not perpendicular.
90.
90. So if they are perpendicular, we would have gotten 90.
What would parallel be?
That's my next question.
Oh, sorry.
What would parallel be?
180.
180 or?
0.
0,
Okay.
yes. So since we got 55.46, that's neither. All right, any question on finding the angle between two vectors?
How often would it most often come out to be neither, or would it not? Like,
It depends on the numbers in the problem.
okay.
I mean, if you pick random numbers off the top of your head for I, J, and K like I did, yeah, it's probably going to come out to neither.
Okay.
Because to be parallel or perpendicular, that's a real special case.
And 45 would be neither as well.
45 degrees, that's neither.
Okay.
Yep. Okay, so this one is finding the distance between 2 points in 3D. So how would you find the distance between 146 and 250?
Okay. First, you would do a square root, and then you would do 2 minus 1 to the second power in parentheses.
Okay.
Plus 5 minus 4 parentheses, and then to the second power, plus 0 minus 6 parentheses to the second power.
Okay, that's that. And now 2 minus 1 squared would give me
1.
1. 5 minus 4 squared
1.
would also be 1. And 0 minus 6 squared.
36.
36. So the distance between those 2 points would be?
Square root of 38.
Yep, square root of 38. And that's how you find the distance between 2 points.
Would you need to get it out of the square, or is that done?
They potentially could ask you to round that to 2 decimal places.
Okay.
So you just type it in on the calculator and you get about 6.1 or 6.2.
Okay.
Yeah. So
I can just put it in the calculator then.
yep, put it in the calculator. All right, the last question we'll take a look at is finding the cross product between V and W. So the way we learned how to do it was with Saris's rule. What's the first thing we write down when we use that rule?
The first thing you would write down,
Mm-hmm.
would you just start doing the cross, or would it be something first before that?
Well, we gotta make that table.
Okay,
that
so
we're gonna
you would
use.
make the table.
All right, so what do you write down first?
Like what you're supposed to put in.
Yes.
You would do I, and next over would be J, K,
And then what goes in the next row right below that?
A1, B2, C1, or A1, B1, C1.
Okay, so in this case, those would be?
That'd be
2,
5, -4.
4, yep.
And then the next one would be 3, -1, 5.
5. Okay, and now what do we do?
You take the first 2 columns and move over to the last right?
Yeah, copy them. So we're going to leave them where they are and then make extra copies of them.
Yeah.
So ij 2, 5, 3, -1.
Okay.
Okay, what do we do now?
You take from the top right on the left, you go down straight right, not straight right. Down right.
Yeah, so we're going to multiply, we're going to start with I times
5.
Yep,
And
what's
that would
I times 5 times 5?
That would be 25i.
Okay, so 25I. Yep.
Then you would go over 1 and do the same thing. So it would be j, -4 and 3, which would be -12i, or -12j.
-12j. Okay, and the next one?
Same thing, you would do be -2k.
-2k. All right, now what do we do?
You do the opposite. So you would take from the right side, you would go down left. So it would be j25.
So we'll start with k and then work our way over.
That would be 15k, but you would make it minus because it's going backwards.
Yep, so we're going to subtract 15k.
I -4 and -1 would be 4k, which would be, or 4i, which would be just -4i. Right?
So -4i. Yep.
And then -10j.
And then j times 2 times 5, that's 10j, but we subtract it. And our last step.
You solve it.
All right, so what would you get?
For the i's, you would get 21i.
21i.
For the j's, you would get -22j.
-22j.
For the k, you would get -17k.
-17k.
Hey.
And that's the cross product between v and w. Okay. Any question on that?
That's how it's going to be on the test, right?
Yep. I'll give you 2 vectors and just have you find the cross product.